Okay, today, Chapter 6, Section 4, we're going to talk about rational exponents. In order to understand what this is, we have to understand what a rational number is. If we remind ourselves, a rational number is any number that can be expressed as a fraction. So a rational exponent is just a fraction in your exponent, okay? Or it might look like this, okay, where a and b are just whole numbers or real numbers. So now, what we need to know is that the power is actually the numerator and the root is going to be the denominator. It's your index for your root. If you remember what a root is, it's just like square root, cube root, it's the radical. Okay, we can call those either thing. Now, when you are dealing with rational exponents, if you ever have a negative rational exponent, stick the negative sign with the power or with the power, not the root. All right. So if I were to simplify these or write these expressions in radical form, all I'm going to do is take x to the 9th, and then I have the square root. The top number is your power, the bottom number is your index here. This can also be written, I could put it as x, the square root of x, to the 9th power. For this one, same thing. Top number is your power, so I have a cube. Bottom number is your radical, so I have the 4th root. Also could be written, the 4th root of x to the 3rd power. Now, for this one, if you remember on the first page, we talked about how if you have a negative exponent, you want to leave the negative with the power. So this is x to the negative 2, and then we have the cube root. Now, when we have a negative exponent, let's remember what we do with the negative exponent. We're going to go ahead and put that in the denominator to take away the negative. So I have 1 over x squared, and then I still have the cube root. You could also write this as the cube root 1 over x squared. This one, if you have a decimal, to write it as a fraction, you basically just have to read the decimal. This is 1 4/10 or 14/10. So what happens is I just have to write this as x to the negative 14/10. Now what happens is I reduce my fraction. I have x to the negative 7/5. Change it to in radical form. So I have the 5th root of x to the negative 7. And now put it in the denominator with the negative. And it looks like this. We could also write it the other way around where the 7 is on the outside. Write each expression in exponential form. For this one, I'm going to change this to x to the 5th. And then I have over 2 because this is a square root. For this one, be careful. This one is tricky because the exponent for the 5 is technically 1. The exponent for the y is 4. So these are going to be separate. You have 5 to the 1/3 and y to the 4/3. Both of them are underneath this cube root. However, they have different exponents, meaning their numerators are going to be different. For this one, notice how the cube is for the 6 and the y. So I have 6y, the entire thing, to 3 over 2. However, you could also, if you wanted to distribute that, if you remember your exponent properties, this could be 6 to the 3 over 2, y to the 3 over 2. Simplify each expression. So I have 64 to the 1/3. Now, instead of just rewriting it, I actually have to simplify. So I'm going to change this to 64 to the 1st power, which I don't have to write there, but I have the cube root. We know how to break these down. We did this in Chapter 6, Section 1. So we're going to go ahead and break it down. We're looking for a perfect cube so that we can cancel it out. So I have 8 times 8 here. And then that breaks down into 4 times 2 times 4 times 2. And if you look, 2 times 2 is 4, which gives me 4 times 4 times 4. Which is the cube root of 4 cubed, cancels, and I'm just left with 4. Now, this is something that we need to remember from the past. I have 3 to the 1/2 times 3 to the 1/3 times 3 to the 2/3. If you remember when we did exponent properties, what we did was we took something like x squared times x to the 7th. What did we do to the exponent? We added them. So this is just x to the 2 plus 7, which is x to the 9th. Well, you can do the same thing here as long as your bases are the same, which my bases here are the same. They're all 3. So I can take 3 to the 1/2 plus 1/3 plus 2/3 To add the fractions, I'm going to take, excuse me, 1/3 plus 2/3 is just 1. So I have 3, 1 plus a half, it's to the 1 1/2. Now I can't write this as a root or a radical expression or simplify yet until I change my 1 1/2 to an improper fraction. So that's what I want to do. So this becomes 3 and 3 over 2. Now I have 3 cubed, the square root of 3 cubed. Rewrite this to be 3 squared times 3 so that you can cancel out your squared. So you have 3 square roots of 3. Now, these are very similar to the worksheet for homework. So I'm going to do some examples. Make sure you read the directions or you'll end up doing way too much work. The directions here say, write each expression in radical form, meaning use your root. So you don't have to simplify for any of these. All you have to do is just change them. So this becomes the cube root, since the 3 is on the bottom, x to the 4th. For this one, I have to change this to a fraction. So this would be a to the 15 over 10, which is a to the 3/2, which is actually a cubed underneath a square root. 3 is the exponent, 2 is the root, the index for the root. Now these directions say write each expression in exponential form. I'm given the radical form, I have to write it as a fractional or a rational exponent. Well, n is my numerator and 5 is my denominator. The root is on the bottom, the exponent is on the top. For this one, I have 5y. The exponents for 5y is just 1. So on the top, you have 1, and on the bottom, you have 2. So it's 5y to the 1/2 power. Now, if you wanted to rewrite it like this, it would be possible because that's an exponent property. Simplify each expression. So now we're going to use these to keep simplifying. So I have 125 to the 1/3, which is just the cube root of 125. If you know what the cube root of 125 is, you can just simplify that. If you don't, just break it down. So this becomes 5 times 5 times 5, which is 25 times 5, which is 5 cubed. Cancels out, this is just 5. Now, look at these. I have, once again, the same base, so I can add the exponents. So this is -5 to the 1/3 plus 1/3 plus 1/3. Well, if you add 3 1/3, you end up with 3/3 or 1. This added together is just 1. So I have -5 to the first power, which is just -5. Now for this one's a little bit tricky. This one you have to look and you have to notice that all 3 of these are underneath a cube root. This is the cube root of 12, this is the cube root of 45, and this is the cube root of 50. And if you remember, we talked about this in previous sections. If they're all cube roots, you can put them under the one radical. So this becomes the cube root of 12 times 45 times 50, which is the cube root. And now we're going to break it down and look for perfect cubes so that we can simplify. So this is 4 times 3, 45 is 9 times 5, 50 is 10 times 5. I still don't have any cubes, so I'm going to keep going. So I have 2 times 2 times 3 times 3 times 3 times 5 times 5 times 2 times 5. And all I did was break those down if I could. And I'll go ahead and draw a line so you can see that. And now I have perfect cubes. If you look, I have 1, 2, 3, which is 2 cubed. I have 1, 2, 3, which is 3 cubed. And I have 1, 2, 3, which is 5 cubed. So I have the cube root of 2 cubed, 3 cubed, 5 cubed. Those cancel since they're opposite, and we're just left with 2 times 3 times 5, which is 30.